everyone. And as I think what might have attracted you is the liar liar. So let's try to debunk what this is about. First, a bit about myself. I'm a computer scientist. I study software, and in my everyday life, I'm trying to improve the developer experience at work, which often come in two forms. I'm trying to improve code velocity, something that industry cares about deeply, but also about developer productivity in more meaningful ways. And as I was on this trajectory, entered large language models, which changed how developers work. So it became just essential to even understand how they are impacting developer experience and what can we do in order to ensure that their productivity continues to improve and we have a code that is of good quality. So as I was talking about this, a problem crossed our attention, which was about the customer support team at AFAS Software. And as you can imagine, like with every software product that you develop, there is a support team ensuring that the clients have access to the right information in the right format at the right time. So there's nothing new really about this, but what changes is when we talk about the scale at which things happen. So there are 3 million clients and a 70-member team, and just in the year 2023, they had something around 100,000 plus queries. And it's a tedious task to answer all these questions, which basically translated to answering one question per minute. And sometimes it does require delving deeper to understand what a user needs from you. So this was the background a few years ago, and then entered large language models. And what it changed was that they thought, how about instead of we doing the search ourselves, let's ask this question to the large language model. So the question was passed on to the large language model, and they were also provided with the context. So in this case, the internal documentations that were available. So using RAG, they were able to generate an answer. And now it's up to the customer support team to decide whether to pass on this answer further or not. And when I think of this, it's somewhere we are changing the responsibilities. So previously, the support person was making the decision, but was also bringing in the knowledge. So either from their experience or looking at this documentation. But in some capacity, this knowledge intensive part was being passed on to large language models. And of course, when our customer support has to make this decision, they are leveraging either their knowledge or the fact that there is a doubt. But something more problematic happens here. So previously, when you were searching for the answer, you were simply looking for the right sources. But now you also have to be a detective looking for, is it hallucinating? Is it giving me the right information? And the wrong answer could be very similar to the right answer. And that's where the problem started, that instead of saving time, it might take actually even longer to respond to the user query, because now you have to verify each and every information that you're passing on. So we thought, okay, let's introduce something else which, at least in some capacity, can help the support team in order to answer the question. So what I'm calling here is correctness is that intermediate, which perhaps can reduce a bit of the work of the customer support team, and they might still have to verify some of the answers, but even if it can answer a subset of the queries, we might be solving their problem. And this is the intermediate that we are going to talk about today, how we can make an intermediate that can help us understand whether the generated answer is correct. If it is correct, you may still need to verify, but if it is saying it's not correct, don't even bother looking at it. So at least you can reduce some of the work there. So here, what we might be doing is we are taking a part of the decision making or the search, the detective part that the customer support team had to do and transport it into a solution. So I'm not going to keep you until the end just to know what the study find. So there's a glimpse of the key insights here. We were able to identify the 55% of the incorrect answers. and this is a QR code of the paper that is linked to it, but our ability to identify the number of correct answers was much less, 26%. And of course, we will revisit how we reach these numbers and more insights much later, but this is just to begin with. Now, where you might relate with these challenges is that what is even correctness? So when we started this study, we had no idea. What does it mean that an answer generated by large language model is correct? And we thought, okay, let's try to figure this out by looking at pragmatic examples. But then we run into another problem. So unlike very large companies which have billions and millions of data points available, not every organization has that. We were dealing with a very limited amount of data, which means no kind of training can happen just by randomly putting the data and hope that an outcome comes. And then comes, well, even though we have all these limits, we still want the solution to be working fast so that we can provide a solution that's near real time. And finally comes the language. The customer support system is designed in Dutch, while most of the research that is around this subject is in English. So these were some of the challenges that we started with. This was the context which defined and shaped the kind of response we can generate to proceed. So the first thing was, what is correctness? And we found that the correctness can be defined in terms of three things. Relatedness. So if you look at an answer and it looks somewhat similar to the question, it's related. Truthful. It's telling you what's true. And the third, it's complete. So how did we arrive here? It wasn't an easy journey. There was no literature that pointed us to what correctness is, but we did three things. So we shadowed how people are working there and when do they consider an answer as correct or not, which wasn't enough, so we designed a plugin. And what this plugin did was that the support team, when they reject an answer, they can manually annotate why they think an answer is incorrect. So we had some 150 data points. That's the size we are talking about instead of millions of data points that generally people have. And then we try to correlate it to the definitions that the literature talks about. And that's how these three terminologies come in. So now going further deeper, there were some works on relatedness. So this is something you can look for cosine similarities or other things to say that how the two contexts are related, a question is related to answer. So which left us with truthfulness and completeness. And we thought, if an answer is not true, why bother about completeness? And that shaped what we looking at truthfulness. And the rest of this discussion is going to be about how we can infer the truthfulness of a response. So, as we talked about this, we actually had one more requirement, of course. Because we had such limited data, we cannot rely on just answering the same questions for which we have training data. So we needed an approach that is domain agnostic. So I cannot ask a question which say so there might be scenarios where we want, if the question has not been asked in the past, it should still be able to provide an answer. So in order to do that, we had to introduce some intermediates. So we needed a mechanism that can take how humans make decisions and translate it into what we can measure in terms of the large language model. And the subsequent part of this talk is going to delve deeper into how can we make something that a human understands and translate it into metrics and numbers which we can measure in terms of the answer and the question that we have available with us along with the context that it comes with. So this roughly translated into 3 intermediate steps. So the first step was understanding how humans make decisions. So you may have less data, but you do know that these people are making decisions some way. So if we can model that, we at least have an understanding that in what cases humans would consider a decision wrong. The second step was, and I'm going now from the opposite side, but the large language models understand metrics. And we needed an intermediate where we can say what heuristics can be identified that can act as an intermediate between these human decisions and the metrics. And we'll go into each of these dimensions, but this is the essence that if the data is limited and you are looking for a solution that is not tied to a question, you may have to think about how humans would make decision and then translate it into metrics. So we were eventually able to analyze two categories of question, the binary. So in this case, it could be, would it be possible to adjust text rate manually? And the second kind of question is when you're asking for an instruction. So how would I adjust text rate manually? So these are the two categories because what we did instead was we looked at for different kinds of question, what would a human look for in the answer? So I'll use the second as an example. So when we started shadowing some of the support staff, what we noticed is that, every time a large language model-based solution is given, they are not doing a very complex job to begin with. It may get complex, but not to begin with. So they were always looking for the simplest way to say, this answer is wrong. And that's where we started as well, that we don't have to delve into much complex details unless it is necessary. So as an example, we build decision trees, learning from how they would say, oh, this answer is wrong, because this was okay. And this decision tree was built iteratively by shadowing, but also by refining it based on how they would make decision. So let's take the example of how would I adjust text rate manually. So since you have documentation, you can see that are any of the steps in the context. And here context refers to the documentation. If that is true, then you may want to think even deeper, that are all the steps that are mentioned coming from the same guideline? If it is true, most likely the answer is correct. But if it is not, it doesn't mean that the answer is incorrect by itself, but then you start looking deeper. Is there any contradiction? Because contradiction might mean that you might have to refer to two different sources. If it is not, then maybe it's a wrong answer, and otherwise you go further and further. So what we learned, the basic is always start simple. And if you can deny it at that level, you don't have to go any further in that level. So this is how we interpreted how humans would make decision, but we are still far from making it machine understandable. So this came us to heuristics and then heuristics to metrics. So if we take the previous example of the context, the heuristic was unspecified components less likely to be true. So you have a documentation which points to the company-specific terminology. And by company-specific terminology, how you can do is take 10,000 most common Dutch words and also the most widely used words used in your individual organization's document. The words that are specifically used for yours is the context terminology that you use. And that's how you can say that if those terms are not being used in the answer, it's more likely that it's just hallucinating or giving you a very generic response. And of course, the decision tree that we build is much bigger than what we show, and the heuristics I'm presenting you are just sample. But it's an example of how, inspired from the literature into individual aspects, we ensured that how humans make decision can actually be translated into something that's measurable. I'll give you another example. So the second heuristics, also inspired by the literature in natural language generation, was two general answers are less likely to be true. I think it's expected that it might be hallucinating if you're not using terminology. But how could we do that? Because unlike English, we did not have this kind of context available to us. So we inferred the complexity from the signal words, and we had to use some of the Dutch learning material that is available, which also identifies, say, the 100 most common words that everyone should know. And then there is next level and next level. So I, being a Dutch learner, I think it somehow helped me in my research to be able to comprehend when the words become complex and how they can be useful for answering the context. So this is how we looked into adjusting the things. So when I talked about that in 55% of the cases, we were able to identify whether the answer is indeed incorrect. This refers to the scale. So if we say 5, where say 5 means incorrect, well actually, sorry, 5 was correct. So if we classify combining insights from all these different metrics, that a question is very likely to be wrong, it was wrong in 55% of the cases. And likewise, when we said with strong confidence that it's indeed correct, it was in 26% of the cases that it was correct. But there is a whole gray region in between this spectrum. So 1 was incorrect and the 5 was correct, but there was 2, 3, 4, 5. And of course, it's much easier to talk about the extremes because then we are either very sure or very less likely. We are very sure, sorry. And everything area in between is where we draw the line. So we notice that if we just cut it in between at 3, we would be able to identify 64% of correctly classified incorrect answers and 79% of correctly identified correct answers. I know it's a bit of a mouthful of things to say, but we know that every time, so the boundaries are not so clear, perhaps how we combine the scores, perhaps because humans are also confused and it's not always clear what we want to achieve. So this is, in a nutshell, what we found. And even just by reducing these 55% of incorrect answers and not sending them to the customer support team, we projected that we might actually be saving something like 15,000 hours a year. And that's already good because now when you know what is not, you should not be looking at, you can at least focus on where you should be focusing your attention. And yes, we only were able to look at 2 classes of categories because how humans make decision changes with the different kinds of question you ask. But I'm sure this can also be extended to other kinds of questions than the binary or the instructional questions that we looked at. But also, when we looked at it, what was more interesting for us is why it is not working. What are those classes of examples where something does not work? So the first category that we observed was that there was a better answer available. So it's not that the answer that was provided by large language models was wrong, but the support team knows something better or more appropriate for that given situation and scenario. And that's again something we cannot infer just from the documentation. But this is a class that exists. The second thing is, when you rely so much on the documentation, we have to be willing to acknowledge its limitation. And if there are software engineers or product managers in the group, they would recognize how amazingly we maintain the documentations and how outdated and updated these things are. So that's another thing. So yes, if you were very keen in maintaining your documentation, this would reflect. Alternatively, you could also see this as an opportunity to update the documentation by understanding what information or signals it is giving to the customer support team. Because even for a new customer support, this might mean that they are learning from this outdated information out there. The second thing is correctness is, of course, more than truthfulness. And while indeed there were most scenarios where just by looking that the answer is not true, we could say it is wrong. But there is, as I previously pointed out, much more than that. The completeness, the relatedness, and only when you can look at this complete picture can we infer whether an answer is right or wrong. Something which I should have mentioned also earlier, so the training data that we had of 150 data points, that was versus by the time we implemented the solution, the large language model or its implementation was already changed. So they had revised how they would ask question, but given that this approach is not tied to any specific question or any specific terminology, we were able to tell for sure that it would still work. And we believe this might have actually improved the accuracy of a result instead of turning it down. And also, when we showed the results that our study generated to the support team, they also refined the prompt in order to improve their accuracy. The other two classes, which I want to highlight, is true hallucination. And what I mean by here is, there were times when there was no documentation available for a question that a support team asked. But we were able to get a good answer. And that's because since it was fetching the data from such a wide landscape, it was able to project what this might mean. And this is another class of observation where, yes, it hallucinates, but it might actually hallucinate in a good way. And finally, well, it's an opportunity or an angel that you may want to leverage. And then there's a class of hard to say. It's too complex that no person was able to point out what makes this answer wrong, just than the feeling, it's not correct. Something is wrong. And that's where we end there. So just to summarize, this study started by thinking that how can we reduce the decision overload that a support team has to make? And since we had limited data and we wanted to generate a domain agnostic solution, it meant that we translate how humans make decisions into a form that machines can understand. Is this solution perfect? Not yet, but it has a lot of potential to offer, especially for small and medium-sized enterprises, which may not have enough data to begin with, but still want that their solution works not just for a specific set of questions, but also for all the emerging set of scenarios that might exist. And for all those who are interested to read more about the paper, that's a QR code for it. And yeah, here's my LinkedIn in case you want to follow up more with me. Thank you.